Okay. So let's, even though we have 2 more minutes, because I typically spend 2 minutes saying stupid things, let me do it now. So first question, how many of you here know what is a CAPTCHA? This kind of systems where you need to enter some letters or, okay. So that's a way to distinguish whether you're robots or humans. That's what they say. This talk is for humans only. So if you're a robot here, you probably should go out. All right, all humans, I'm happy. I have not experienced talking to robots. I don't know how to feel their emotions. So, next question. How many of you do you know how to tune Postgres? At least a bit. All right, few hands. So I guess you're here to learn about tuning Postgres. Hopefully learn. I'll tell some stories. Maybe you know everything. Maybe you will get something back. Okay, good enough. So I'll just wait until the official hour for recording's sake and all these things. Okay, ready to start? Okay, so let's go for it. First things first. I'm sorry I am not able to say any more than "Privyet" in Russian. Actually, I always plan to have some sentence, some initial introduction story in Russian, and this time I didn't have time for that. It's very shameful for me because actually have a Russian girlfriend. But English is such a universal language this time that I will also use English for this presentation. Sorry about that. All right, so we're going to talk about Postgres configuration for humans. The purpose of this talk is to make it more humanly, let's say, accessible, how to tune Postgres. A little bit about myself. Basically, you know, these are my coordinates. I'm the founder of some companies based on open source development and mostly Postgres. Right now, I'm working on a project called OnGres, where we are doing hopefully things for humans and Postgres. We do a lot of R&D in databases, so we created products like ToroDB, which is a database which helps you move unstructured data from from MongoDB to Postgres. And now we're also working on all the tools to help the Postgres ecosystem. Feel free to ping me on Twitter or you know, my email. Everything is basically public, so feel free to ping me anytime. A little bit about my company. As I said, we do this kind of software development, R&D on databases, and we also provide services for Postgres. Right. Let's go to Postgres configuration. There's basically, the configuration is mostly concentrated on one single file, which is called the postgresql.conf file. However, there are some other bits and pieces where you can also find Postgres configuration information that are not here. The most obvious example is pghba.conf, which is a place to put all the authentication. Also, if you're running Postgres with replication, which if you're not, you should, then you probably are using recovery.conf, where you basically put how to work as a secondary node, how to connect to the primary instance, and that's a place where there's also Postgres configuration. Actually, there's an ongoing effort to integrate the information on recovery.conf into postgresql.conf, so that it will be concentrated on a single place. HBA is just about authentication, so it's kind of a different thing, and definitely the format is not compatible. So it's a different story. But there's more. There's also initdb. initdb is the mechanism that you use to create the cluster at the beginning. Sometimes it's done automatically, depending on your installation. Sometimes you do it manually. And there's also configuration options, which you can also only set at cluster creation time. Cluster in terminology of Postgres is, you know, when you create the database, right? So there are some options you can only set there. So it's strictly not configuration, but something you can tune appropriately. We're going to talk about this. There's also configuration you may set on a per object level. Like basically, you can tune many parameters related to tables, to objects on the database in general, on a per object basis. Like, for example, fill factor, which is a percentage of the table that you want to fill with insert data in order to make or not room for possible updates. This is an important factor to tune, for example, depending on the number of updates in a table. You may want to keep the fill factor high, for example, if table is insert mostly. So you don't want to leave room in the pages for possible updates if there's not going to be updates. And you can do this on a per table level. So these are basically the main parameters, the main configuration places you're going to find. But there's even more. There's like advanced stuff. There's the development parameters. Those parameters are something you can tune also in postgresql.conf, but are not present by default. You need to look for them and to enable them, because otherwise actually they're advanced. You can corrupt your data. Actually, they're used for recovering corrupted data, but they can also even corrupt it. So just Google them. And there's also compile time defines macros in C, where you can also change some parameters of Postgres configuration, like, for example, the page size or the wall segment size. You can also tune them this way. So before doing this talk, I was thinking, like, what are the reasons to tune Postgres? You know, it sounds good, right? You come here, learn about this, you hear about this, you go back to your home or work or whatever, and you start tuning Postgres. But actually, why? Can it run by default? You know, can we just go and run Postgres? Well, actually, there's many reasons, and I was thinking of all of them. So here are. So basically, for example, if you tune it, you will only listen localhost. Probably you want to expose your database to their local network. So, you know, you want to tune this. Or you want to enable replication, which if you're running Postgres less than 10, it won't work unless you configure Postgres. You may want to enable wall archiving for disaster recovery purposes. You may want to set parameters by default so that all applications will use those defaults. You may want to set up the number of maximum connections. This is something everybody tunes. We're going to talk about that because, you know, some application developers are complaining that the database is rejecting their connections after 100, which is the default. Or to enable the checksums. It's on INetDB. We're going to talk about that. Or just basically to set up compatibility with older versions. Sometimes you need these parameters, and you know you need to tune them. Or also, you know, for example, to load dynamic libraries. You know that Postgres has an extension mechanism called extensions, where you can just load dynamically new libraries, and you need to do this at configuration time. So these are all the valid reasons that I came up with to tune Postgres. I hope that they are enough. They will convince you to go and make the effort of tuning Postgres. Am I missing something? Any other reason to tune Postgres? Anyone? Oh, sorry. Performance. I forgot about it. How could, right? So of course, everybody wants performance. Everybody loves performance. We want to make Postgres perform better. So let's tune for performance, of course. So the usual advice about performance tuning is don't do it, don't do it, don't do it. First of all, don't fall into premature optimization, right? Probably you're going to tune wrong. Probably you don't measure correctly. It's going to take a lot of effort, so just don't do it. Well, in Postgres, it's actually a different story. In Postgres, the recommendation is do it, do it, do it. Because otherwise, your performance is going to be lower, let's say it that way, from what it should be. And Postgres is an excellent database, so don't make it perform very low. Actually, unless you're running on a Raspberry Pi first generation, yeah, that's actually kind of the hardware, like the default values for PostgreSQL file are tuned for. So unless you're not running on a Raspberry Pi, you should probably tune Postgres. Now, usual advice about benchmarking, you know, use your own benchmarks. There's PGBench, and everybody uses PGBench. It's so general, I'm also going to be using it today, right? But don't do this. Just run your own benchmarks, because your use case might be different from others' use cases, and definitely from PGBench. PGBench, you can also use it, but just use your own benchmark, right? So, basically, we're talking about performance, and I want to demonstrate how useful it is or not to tune Postgres. So this is basically what the tune Postgres config compares, and it's not really super tuned. It's just a bit. And this is actually on a low-level machine. It's an 8 gigabytes of RAM, 2 CPUs on Amazon. On higher-end machines, the difference is significantly higher. But I just wanted to show that on a normal, low-class, middle-class machine, right? Just tuning some parameters. I think this configuration was just like 15 or so tuned, like not a lot of them, right? What a performance advantage it is already in terms of transactions per second. So higher is better. We're talking about transactions per second. And you know, we're getting much more with a tune config, which is this clear blue, than with a dark blue. It's roughly 40–50% in most cases. This is with a growing number of connections, so we also see how it suffers under heavy contention, the configuration. Really, a 30–40% is worth the effort. You know? Could be, again, could be higher on high-end machines, so definitely worth it. But a benchmark is not a benchmark until we also analyze latency. And we're going to talk more about latency today, if we have time. Because latency goes up with the number of connections, but here you can see that on a tuned config, it still stays lower all the time. So not only you'll do more transactions per second, but those will react quick here. So you'll have a fastest response time from your database. So these are probably two performance compelling reasons to tune Postgres. Now, how easy it is to tune Postgres? Well, actually, there's more than 200 parameters to tune. And I'm not kidding. There's significantly more parameters, but not all of them you can tune. But tunable, let's say, there's more than 200. They're classified into 40 categories and subcategories. If you take the sample PostgresConf file that comes with Postgres, it has 650 lines, including comments, definitely. And it weighs 23 kilobytes. Well, so that sounds like a bit of a challenging task. So out of you who tune Postgres regularly, how many parameters do you touch, do you tune, let's say? Raise your hands, like 2 or more? Okay. 5 or more? 10 or more? Nice. 20 or more? 3 hands, 4 hands, 5 hands? 40 or more? Yeah. 200 or more, I'm not going to ask. It's obvious, right? So, yeah, I mean, it's not, there's a bit of things to do, right? So, it's not only because of the number of parameters, but also the data types. The data types can be integer, real, string, enumerated values, real booleans. Even worse, the numeric values may have units. And sometimes even the units are a little bit like uneasy. Like, for example, units of 8K. Okay, so if you see, 134 of that, you need to do the math. So it's not easy sometimes. Or there's a synthetic unit like CPU tuple cost, number 3. Okay, so what does it mean? So it's not trivial. Actually, it gets worse with every release. So this is the number of tunable parameters per Postgres version. I need not to explain this graph, I guess, right? So, some ideas. All I want to do here today is to give you some advice. I'm not going to give you hard numbers. So I'm not going to give you put number 3 on CPU tuple cost. Because your environment may vary, your benchmark may vary, your load may vary. There's a lot of things here. I'm only going to talk about a few dozens. I'm not going to talk about 200 parameters. We'll spend the whole day here. And probably you don't want to do that. I definitely don't want to do that. It could be interesting, though. And I'm not, as I was saying, I'm not going to give you the hard numbers. I'm just going to tell you some hints. You need to do the homework. Sorry. if you were thinking of coming out of this session with all the recipe and just copy and paste it, sorry again, right? You need to do your homework. You need to research. You need to understand the values of parameters because they change a lot from environment by environment. But the main reason why I'm saying this is because I'm probably wrong. So don't trust what I'm saying. Yeah, just to use it as an idea, but nothing else. And of course, my opinion may differ from others' opinion. So, really, let's get it started. initDB. I mentioned that this is the executable you use to create the initial Postgres cluster database instance. So it is sometimes run transparently for you. So like distributions like Debian or Ubuntu just run initDB for you. If you want to tune it, like use non-defaults, then you need to basically delete the cluster and run it by yourselves. I actually recommend you to do that. And you can use some of these parameters. Encoding, unless you know what you're doing, you should probably use UTF-8. If you're not sure, use UTF-8. This is also by the typical default, so nothing to change here. However, for example, data checksums. This is a real important parameter that not everybody uses. It helps you detect early data corruption on your tables if there would be like a failure of your hardware, right? And it has a small performance hit, but it's typically very small, typically contained within 1 or 2%. And it's worth your data, so enable them. But again, don't trust me. Go on benchmark if you're concerned about a possible performance drop. Also, you may change the username if you don't want Postgres to be the super user username. And also, of course, play with the locale, or how you want the data to be ordered, and so forth. Connections. This is one of the most usual performance, or actually problems when configuring Postgres. So there's a parameter called max connections, and this is a hard limit. If there's more connections than this number of connections, Postgres will start refusing them with a message called connection refused. So typically what happens, you install the Postgres database, you don't tune this parameter, you fire the application, and then developers came crying and say, your database is not accepting us. It's rejecting connections. We cannot work with this database. So what do you do? Okay, I've heard two answers. I'm gonna pick them in a different order for whatever reason. So let's talk about first raising the number of connections, right? It's pretty obvious. Let's raise it. It's there. You read the slide, right? No, you can't. Okay, so let's raise max connections, and we can make room for more connections. Now, the problem is the way Postgres works is that it will create a new operating system process per connection. And a given process at the operating system level is going to be handled at one time by one core, one CPU. So how many cores do you have on your machine? Hundreds? Thousands? Could be, these days are crazy on times, of course, but probably not. Probably you have a dozen or a few dozens or less. So actually, of course, you have hopefully you're running this on a time-sharing operating system where you can have more processes than cores, and the kernel will schedule among them. That's okay. However, think about all the contention that this creates. If you're going to create hundreds or thousands of processes, there's a scheduling overhead. The kernel needs to assign them to different cores. But what is even worse, there's a problem with cache trashing. In Postgres, all the I/O happens through memory. So if you need to read data from one table, it needs to go first through memory to share an area called shared buffers, and from there processes will process it. Now, if you have thousands of processes, each reclaiming its own part of memory, you're going to be loading data into memory and probably unloading it for the next process to come to load it, and then it will be preempted again by the time-sharing operating system, and you're trashing the cache. Obviously, Postgres is more smarter than this, but still, performance will suffer. So yeah, actually, the solution is, not to raise max connections. Let's analyze this. If we hit Postgres hard with a huge number of connections compared to the size of the instance, we're talking about a 2-core instance here, right? And start doing 10, 50, 100, up to 500 connections, well, we see initially the solution works. You see that the number of transactions per second, which is our benchmark here, it's growing, not very much, but it's just growing a bit. So it looks like this solution is good. Anyone can tell me why this solution is not good? Latency. Let's look at latency. We cannot only look at the throughput, at transactions per second. I heard this was over there. Thank you for that. So yeah, let's add the latency. Now the picture clearly changes, right? Latency, less is better, right? Of course, so this is basically almost exponential grow in the latency. Our requests that were being processed in basically 0, a few milliseconds before, now could take up to a second and a half to be processed by the database. So Postgres is able to handle the load. It's pretty good at this. But the latency, we will start taking a second and a half to respond to our clients. So this is definitely not a good thing to do. So how do we fix this again? How do we fix this problem of max connections? You would say it over here. PG bouncer is the solution. Thank you for that. So you said connection pooler. The connection pooler will basically queue, rather than reject as Postgres does, it will queue the connections. It will hold them there until there's enough room. So what we do here is actually lower max connections. We prevent the problem of connection refused by using a connection pooler like PG bouncer. Lower the number of connections to make a more efficient use of the database. Now we're hitting the database with actual use. We're keeping all the cores busy, but with a few at a time processes, so that the cache is not trashed. Now, how do we dimension this? Again, I'm not going to give you a number. However, we came up in our company with a formula. This is not Postgres documentation. This is our own. So again, treat it with a grain of salt. But basically, the number of connections is actually affected significantly by the percentage of utilization of the connection. So if you take a connection, your program opens a connection and goes off to sleep, like we do in Spain, we go for siesta. No, we actually don't, but we like to. And then you go back, and then you do a query, and then you go back and wait again. And then if your utilization is like 10%, you can actually multiplex, let's say, 10 of those queries in the same core, because the operating system will say, oh, waiting for I/O, and will preempt it. So basically, if you take the number of cores divided by the effective percentage of utilization of the channel, this is going to give you a bigger number because this is less than 1, of course. And then you multiply by a scale factor. This is a little bit hand waving. So I would say, 2, 3, 4. Basically, to increase the number of connections a little bit to give more room for all the inefficiencies. And also because of the operating system is able to handle well on Postgres a higher number of processes than the actual number of effective cores. So you can accommodate for spikes and so forth. Some numbers typically, with a normal machine, you go 50, 60, maybe even up to 100, but definitely no more than that. 24 cores. The previous benchmark was only 2 cores. Oh, the scale factor, you mean? No, if you would take 24 cores, right? Yeah. Okay, so if you have 24 cores and let's say effective utilization connection of 50%, this number will be 48. Then if you add a scale factor of, let's say, 2, that will mean 96. So that's probably like a good number, right? And again, connections will not get rejected because there will be PG bouncer in front of it. So more parameters right now. We have shared buffers. This is the second most tuned parameter, I would say, in Postgres. This is a shared memory area. This is a critical parameter. Now, the typical advice is just set it to 1/4 of the RAM, and then tune another parameter, which is kind of a sister parameter called effective cache size, and just set it to 3/4 of the RAM. Well, yeah, that's a good point to start with, but really don't just do it and go away. Because 1/4 is too small on small machines, and it's probably too large on too large RAM machines. What is too small and too large? Yeah, that depends. On the other side, effective cache size, it's not that really important parameter. And it basically says all the available memory for the operating system to cache. So Postgres has its own cache, the operating system has its own cache, and effective cache size should be like the cache of the operating system. However, the cache of the operating system is actually the whole memory, 4/4, minus shared buffers, 3/4, but then minus the rest of the memory used by Postgres and used by the operating system. So if your database is not alone, it is together with a J2EE server, for example, you need to take that into account into effective cache size and decrease it accordingly. But also Postgres has some other areas, like basically maintenance workmaam or workmaam itself times the number of connections, where it's going to also take some more memory. So, typically this is less than 3/4. But again, you need to benchmark this. This is an important parameter, just benchmark, because performance may change. So just don't buy the 3/4, 1/4 rule and don't think more. Think a bit more. Workmaam. This is a very important parameter. The good news about workmaam is that you don't need to restart the database. You can even change it on a per connection basis. Everybody can change it. Every user can change it. That's the good news. Bad news is that nobody does it. And if it's too low, workmaam is actually memory local to the process, and it's used for some operations, like basically sorting, for example, or creating joins, hashes on operations that require a join, like a hash join. So if the memory is too low, it's okay. Postgres will just use disk, and probably will change the algorithm for sorting and so forth. And yeah, of course, that's not what you want. However, if you put it too high, then this is per process. So if you have a lot of processes, then you'll have a lot of memory being used. This is yet another reason to keep max connections low. And also, it depends a lot if you're OLTP or LAP or data warehousing. So if you're OLTP, typically workmaam of maybe 10 megabytes may be enough, because you're not doing really big operations. You're selecting by primary key or whatever, a few joins here and there. If you're doing OLAP, maybe you need in the order of dozens or even hundreds of megabytes. If you're doing data warehousing types of queries that takes many hours and do really complex joins and shorts, you probably need gigabytes. So it really depends on your use case. You cannot say, yes, put this number. You're probably wrong. Other tunables about memory and disk, we have maintenance workmaam. This is also very important because it's used also local memory for other processes like vacuum to perform operations like vacuum, like create index to check the foreign keys. So this, you should also raise it. The min and max wall size, these are parameters that only affect your disk space. So if you have a fast disk, because you should put your wall files on a fast disk like SSD. And if you have a disk, you know, this is basically a few gigabytes. Unless you have like tiny disk, just be generous, right? It will make the checkpoints less frequent. Checkpoints are a source of slowness of the database. So make the minimum at least 1 or more gigabytes and the maximum go up to 50 or 100. You don't need more than that. That's already big enough. Some optimization is to put stats temp directory on RAM, on a RAM disk. It is not a significant performance improvement unless you have some particular scenarios. But if that's your case, you need to make it big enough because you may run into trouble if it's too small. So only tune it if you actually experience some problems with a lot of contention on the statistics. Actually, it was more of a problem in Postgres 9.3 and before. It is no longer a problem if you're running something more modern, of course, which you should. These parameters are important because if you need to change them, you need to restart the database. And you don't want to restart your database very frequently, hopefully never. Because if you restart your database, all the connections are lost. So it's a downtime, effectively. So plan carefully. Before deploying into production, review these parameters because you don't want to cause a downtime just to reconfigure them. Listen addresses is obviously, where your Postgres is listening. SSL, whether you want SSL to the database or not, and this is a long debate. Huge pages, by default, is set to try. Huge pages typically should increase performance. In most cases, they decrease it. So by setting them to try, if they are enabled, they will work. So unless you tune and you're sure that it provides some advantage, you should probably set it to off. Shared preload libraries, if you're loading dynamically extensions into Postgres, you should set this parameter and put here the extensions. This is important. The logging collector, unless you want to log to standard output, you're gonna tune this. Wall level, unless you're in a modern Postgres like 10, basically, this is set to minimal, and that means you cannot replicate. And probably you want to replicate. Or probably you want to enable replication or even logical replication in Postgres. So please do go and set this to logical before you might discover that you need this and now you cannot cause downtime, or you need to actually do it. The same for archive mode. Archive mode is for wall archiving. You may use this to set up backups, disaster recovery. Set it at the beginning because otherwise you need to restart it. And even if you're not going to use it at the beginning, the archive command, which is a command that Postgres executes, just set it to true so it will work, right? And then you can change it. And the cluster name. This is a very stupid parameter, but actually it's very useful. Just give a name to your cluster, to your Postgres cluster, such that if you're running multiple clusters in the same machine, you can distinguish which is which. This is very convenient. And you cannot change it without restarting the database. Now, what I call the tyranny of the max parameters. Postgres seems to be very strict about controlling which parameters, the resource consumption in general. So there's a lot of max whatever parameters, which determines the maximum number of resources of a given category you may use. But again, most of them require restart. And it's better to just control the usage. You're probably DBAs here. You can control what people are doing on the database and not limit yourself and then exposing yourself to restart. So a few examples of those. Maxwell senders, this controls the maximum number of replication channels, either for backup purposes or for replication itself. Yeah, well, you know who's going to replicate, who's going to do backups. Because by default, most of these parameters are 0 on versions less than 10. 10 comes with much better defaults, but less than that, it's 0. You probably want to replicate, right? Or take backups using streaming replication. The same with replication slots. If you're using replication slots, either for backups or other options. The parallelism, since Postgres 9.5, there's some option to run parallel queries in Postgres, and the number of parallel processes is controlled by these parameters in a very strange combination. But again, you need to tune them without restart. Autovacuum max workers also use more cores for autovacuum, if that's, that could be important. And max prepared transactions, if you know what it is and you're doing two-phase commit transactions, then this parameter is 0 by default, and you need to enable it. And again, it requires restart. So these are a lot of parameters that control this resource consumption that you will probably want to raise before exposing yourself to a downtime because of restarting the database. All right, that was a bit. Any questions so far? No? Okay. AutoVacuum. Who has faced problems here maintaining, running, supporting a Postgres database with AutoVacuum? Yeah. Okay, I should do this like, I don't know, a lot. Yeah, AutoVacuum is one of the most frequent operational troubles in Postgres. You know, of our Postgres support customers, I would say like 90% of them have at least once raised an issue because of AutoVacuum. AutoVacuum is just a cleanup, right? So it's just Postgres, when you say delete or update, it actually doesn't do it. It just mark the row as candidate for deletion. And theoretically, this space should be reclaimed by other inserts in the future. That is true as long as someone goes there, like running a process called vacuum, and make sure that that row is not used by any other transaction and is actually free to be reused by others. If this process is not aggressive enough, it does not revisit everything to make sure which rows are reclaimable or not, they will not be. So rather than reusing this whole space, it will start inserting at the bottom, and you will start to accumulate what is called bloat. Bloat is unused space, unused rows. And this makes your database slower because it needs to read more data to actually read the usual data, the data that is live. So it's not that you're going to get the wrong data, it's just the database is going to be slower. And this is specifically bad for indexes. And the problem is that AutoVacuum by default is tuned very conservatively in Postgres. So you almost always need to tune it. Some notes, some of the parameters are set to -1 because Postgres distinguishes between vacuum, which is an operation you can run from the command line, then autovacuum, which is the one launched automatically. If on autovacuum parameters you see -1, this means look at the equivalent vacuum parameter, and you can tune them differently. You can tune them differently, vacuum from autovacuum. I haven't seen a lot of people doing that though, but at least you can do it. So, oh, by the way, the autovacuum, vacuum, or analyze scale factor is also a parameter I recommend you setting by table. This is basically a parameter that says when a given number of tuples have been dirtied on a table, we will fire autovacuum here. And this parameter may change from table to table. You may want this on heavily updated tables to run faster than others. So you may tune this on a per table basis. However, also tune some general defaults, right? So how to tune autovacuum? Well, I probably cannot tell you this in 2 minutes. But as a general rule of thumb, remember, it is very conservative. So the first thing you need to make it is more aggressive. How do you make it more aggressive? Basically raise a parameter called vacuum cost limit, which basically tells how much work vacuum will do per unit of time, and also decrease the time that it naps, because it runs a bit and then pauses, runs a bit and then pauses. So the trick here is to increment the amount of work that it performs per round, and also decrease of the sleep time, which by default is like 10 milliseconds. 10 milliseconds on computer is ages, right? So raise vacuum cost limit, reduce the delay, and also if you have a lot of cores, use a few more, because the default is 3, to use 3 cores for auto vacuum. If you have 24, you may give it maybe 5, 6, 8. It won't significantly impact your throughput to the database. Checkpoints and PGWriter, the background writer. Very quick summary, checkpoints are basically the process that Postgres uses to conceal the information that is in the disk and the memory. Whenever checkpoints happen, it needs to typically download a lot of data from memory to disk, do a lot of writes. That creates a spike of I/O. Now, the PGWriter, the background writer, tries to spread this load throughout time so that these I/O spikes of the checkpoints are less hard. Now, how to tune this? Basically, the same rule as AutoVacuum. By default, the background writer is not very aggressive. You need to make it more aggressive. Also, by the same method, basically augmented work that it does on a per round basis, this background writer, and decrease the nap time, which in background writer terminology are decreasing the background writer delay and augmenting the number of pages that it processes per round. As per the checkpoint, we actually want to spread it more in time to make it happen less frequently, so these spikes are less frequent. Because if we are tuning now the backgroundwriter activity to make these spikes lower, we can also separate the checkpoints. So make the timeout a bit bigger. Make sure, of course, we have a significant amount of wall. Otherwise, the checkpoints will happen no matter what we say more frequently. And also raise the checkpoint completion target. This is a very complex parameter, but basically says if we have a checkpoint timeout of 15 minutes, we'll try to spread the I/O through at least a fraction of this to perform the I/O. So it will try to spread the I/O more than the default 0.5. So, well, these are very technical, very deep parameters, but at least I want to give you a general idea on how this goes. Logging. Well, this is actually one of the things people don't spend a lot of time because it doesn't affect performance. Well, unless you do it really wrong, but it doesn't affect them in a way that you don't want. But it's actually complex. There's more than 24 parameters. Sorry. There's more than 24 parameters there, right? That's a lot. But I would suggest you to spend some time here because it helps you when you need to debug performance problem on your database. So basically, turn on logging collector. Otherwise, your logs are going to be lost on the standard output. Definitely log checkpoints and log connections and disconnections. Remember what I was saying about max connections? If you don't log connections, don't log disconnections, you're not going to know very well how many connections are hitting the database actually. And a last round of parameters that could be interesting. Password encryption. If you're using Postgres 10 or greater, well, use it. You can change it to use Scrum. Actually, it's going to use the SHA-256. This is used for Scrum authentication. You may want to do that, definitely. Effective I/O concurrency. This is basically a parameter that tells you how many I/O channels you can throw in parallel to your disk subsystem and increase performance. Basically, if you have moving spindles, this is very easy. It's basically the number of effective moving spindles. If you have SSD, probably more than one is good, but also do your own benchmark. The max standby archive streaming delay and the hot standby feedback, these are three parameters that are a bit complex to explain here in this short amount of time, but basically it suffices to say that they basically, when you're running a replica for read queries, you may, and there's conflicting operations, like for example, a vacuum is triggered on the master and you're doing a long running query on the secondary node. You can shift the burden on maintaining more load on one node or the other one, depending on what you want to do. You want to cancel the queries or you want to augment the amount of wall on the master system. And these parameters let you control this. So it's just a balance between the primary and the secondary, where you want to put this extra load of maintaining more wall files. The default statistics target. The statistics are used in Postgres to compute optimal query plans. By default, it computes 100 of values per table. You may want to raise this number for some heavily used tables or big tables where you want the quality of the planning statistics to be higher, but you can change it per table. And this radio is very important, especially if you're using SSD disk. The random page cost and the sequential page cost. These are absolute parameters on an abstract unit. It's just a relative measure among them, and basically says how much expensive it is to read a page from a random area than from a sequential read. On SSD, this difference not that significant, and if you keep the default, which is 4 and 1, which means it's 4 times more expensive to request a random page than to read it sequentially, which, and again, in SSDs is not true. You're basically favoring sequential scans. In other words, reads from tables. In other words, not to use indexes. So actually, if you don't do this parameter and you're on SSD, probably your indexes are being misutilized. All right, so was that too much? Well, hopefully this will help, but there's a few bits here. So why not use a tool to help us, right? So there's a few tools out there. This one is called PGTune. And well, you can basically get 10 parameters out of this tool, out of which 3 you're already putting there. So you get 7. And some of them are just basically following this 3/4 rules, 3/4, 1/4. My recommendation is that this is telling you basically nothing. Don't get me wrong, it's a great tool. but you probably already know more than this after this talk. There's a similar one called pganalyze. Gives you a few parameters more, but in my opinion follows exactly the same path. So, in my very honest opinion, we need a new tool. And actually the tool, again, in my very honest opinion, should be more concentrated on helping you than really telling you the numbers you need to put in there. Because as you've seen, hopefully today, one size does not fit all. And I cannot even give you today hard numbers to put there. So you probably should have a tool to help understand what to put there rather than this is the number. And because we felt in our company this does not exist, we are building this tool. So it's called PostgreSQL Code.nf. Yeah, there's a shift on the dot, but other than that is the PostgreSQL.conf file. Yes, this is actually domain name. And this tool is being worked on. It's going to be a free tool to use to configure Postgres. And it's basically a web configuration tool. So just take your postgresql.conf, just drag and drop here, and it will nicely present integrated help. You can post some comments. You can share your config file with other peers. You can have others give opinions, comments on the files. It provides you with recommendations similar to what we have seen today here in this talk. Just more recommendations that just set this to 1/4 and this to 3/4. And you can manage your configurations from the website, and later you can use a REST API to download or to change the configuration, and also download the configuration in several formats. So, as this tool is not launched today, but we're welcoming beta testers and a period that we will open soon, I will encourage you to go to this website, postgresql.code.nf, and subscribe to the mailing list so you can become a private beta tester, which will be open soon. And with all this, I'm open for questions. Thank you. Any difficult question, please? Or easy? No? You already know how to tune Postgres? Oh, there's some questions there. Excellent.
Hey, thanks for the great talk. And I wanted to ask, what is the normal usual number for dead rows on pretty big table? Like, I don't know. We just usually adding and deleting rows.
Well, the default is to start doing vacuuming and analyzing process at a 10%. Seems like a reasonable value, but if you think of what is 10% on a large table, that's really a lot. So on a large table, I would say definitely less than that. Maybe 2 to 5%, but even 2 to 5 is too much for me. This could be millions of rows.
Okay,
so
thank you.
Sure.
Hello, I have a question here.
Oh, sorry.
What tools would you recommend for troubleshooting slow queries and find the spots where which parameters are misconfigured?
Okay, that is a really tough question. So the slow queries. First of all, you can enable some logging of slow queries in Postgres with log mean duration, but that's not the good way to do it. There's an extension called pgstat statements, pg_stat_ statements, which you can load dynamically as in load parameter, and then configure it to record the performance of the queries. This is the best starting point. pgstat statements will basically record the performance of every single query you execute on the database, and then you can query a view called pgstat statements, where you see the top queries ordered by time, average time, average latency, so you can see all the numbers there. This will give you a general overview of the, let's say, the 10 most expensive queries on your system, either by query time or by aggregated time, because it also counts the number of times you execute it. If you have a query that is 2 hours, takes 2 hours, but you only run it 1 per month, probably it's not a problem. However, you have a query that takes 3 milliseconds, but you run it millions of times, probably you need to tune that one, right? So pgstat statements will give you both. Now, once you have that, you should go and look at the query plan. You should use explain, actually explain, analyze verbose, and several options you have on explain to tune the query, to analyze what is the performance of that number of queries that you want to tune. And finally, there's another module called autoexplain, which will also throw to the logs some explain information about the query. So you will also have the explain plan that was used in the past. Because if you run explain plan right now, it could be different from what you have in the past.
So I want to ask about that question more specific. Okay, we have a slow query, right? And then we do the explain. It's like isolated case, right? But if there's a backup going on and it's affecting the query, it's making it slower. So when I do this pgstat statement, can I see the other queries that happened at the same time when the slow query was there? Maybe the copy affected that, it made it slower. So because I don't know now why, sometimes every hour the query gets super slow, and then the rest of the time it's fast.
Yeah, so there's some reasons for that. That's why I said it's definitely not easy to do this. First of all, because there could be system processes running, like a checkpoint. Those are not going to be logged in pgstat statements, or you're taking a backup. Probably you know better than the rest of us, right? However, there could be other differences. A single query with different parameters may yield different query plans, right? Basically, Postgres, based on this, what's called selectivity or cardinality of a query, if it thinks that the query is going to return like a small subset of the table, number of rows, it may use an index. If it thinks it's going to return a significant percentage of the table, it may not use the index. If you're like close to the edge, and depending on the parameter and based on the statistics, it may choose one or the other path, and one of them may be wrong, either to use or not to use the index. And depending on the parameter, you may be shifting from query plan to query plan differently. How do you solve that? Probably running more analyze and vacuum. Probably analyze is not well updated, so the statistics are not updated. Maybe you're not capturing enough statistics from the table. Maybe the sec cost and random page cost are not properly tuned, so maybe in this case, an index is used, and then when the parameter changes, the index becomes not used. Then it switches to a sec scan, which is much more expensive. But it's non-trivial, and apart from that, you need a lot of monitoring.
Thank you for presentation. I'm here.
Thank you.
I'd like to ask about vacuum tuning and raising these parameters on vacuum also raises disk usage. And I'd like to ask, what is the good proportion between raising disk usage on vacuuming and using it on SQL and other things?
Yeah. Okay. The point here is that by default, vacuum does almost nothing. The by default configuration does so little amount of work that you need to raise it yes or yes. If I recall correctly, the parameter by default is 1,000 units of work, which means 1,000 pages. That's 8 megabytes. And then it naps for whatever amount of milliseconds. So if you have a disk that is more than 8 megabytes per second, which is what my USB drive does in 4 or 5 times, you may want to tune it. So there's of course a balance, but the problem of bloated tables, which means tables that are not vacuumed frequently enough, are pretty big, because you're reading maybe a gigabyte just to have half of it of useful data. That's also creating a lot of I/O extra. So of course you need to check whether the speed of your drives, what do you have there, and how much do you want to shift. By the default is very low. The good news is you can do more or less the math very easily.
Okay, thank you.
Thank you for presentation, and I want to know how often do you recommend to turn off synchronized commits option?
Okay. So synchronous commit, it's a parameter that allows you to delay the how to apply a commit to the database. It sometimes performs some advantages in terms of performance. It depends a lot on the use case. However, it breaks a little bit the contract between the client of the database and the database itself. You may return to the client like saying this commit has actually happened, whereas it gets lost if the database crashes. So you're sacrificing data safety. The database will be safe. I mean, it will recover if it crashes. It will not get corrupted. It will always be safe, but you can lose.
So you recommend to use it, to turn it off
Yes.
sometimes?
My recommendation is not I mean, no. I
It's
recommend
not a crime, yes or no? It's not. It is a very good deal.
It,
in
is,
many
it
cases.
really depends on your use case. You know how important it is for your clients of the application to may lose spurious and a commit. If it's not a big deal, then yes, it can provide significant benefits sometimes. My default would be say never turn it off.
Never turn to.
Yeah, yeah. I prefer to be on the safe side and prove me wrong, and then you need more performance, and you cannot buy another machine with more CPUs, and then we will discuss.
Thank you very much. So you don't advise to turn it
No,
off?
no.
Nobody. To nobody in your life, you never recommended it.
If your application is, for example, inserting logs into the database, and you're okay losing 1% of them, then I will say turn it off all the time.
Thank you very much.
Another one question. You've mentioned that random and sequential page cost for SSD, and are there any other parameters that are also very important for SSD overhead there?
So if there are other parameters important for SSD, actually yes. The other one I mentioned briefly today is effective I/O concurrency, which is like the number of concurrent I/O operations you can throw to Postgres. That number is typically more than one on an SSD. They behave well. Actually, you can increase performance, but you should measure it. But there's also parameters that you may want to check, but not at Postgres level, but operating system level, like sysctl. You should go to sysctl apart from the trimming parameters. You must also check with SSD disk to make sure you don't burn them, right? You may want to look at the read-ahead parameters, for example, how much in advance you're able to read or to cache from these disks. Postgres land, unless you really want to go very deep into the optimizer tuning parameters, which I've seen very few people do, you're probably good with that.
Thank you.
Unfortunately, time is up, but you can ask your questions to our speakers out of audience. Thank you.
Sure. Thank you very much for attending.